This is a great little probability question. You are 5 blocks south and 5 blocks west of your friend. You begin walking only north or east, and at the same time your friend begins walking only south or west, 1 block at a time. If you both walk at the same speed, what is the probability you meet each other on your walks? So this is you. I've kind of drawn a diagram here. That's 5 blocks. So if you count, it's like 1, 2, 3, 4, 5 south, and then 5 across to get to your friend. So I'll write friend. And you're both going to start walking basically towards each other. So what's the probability you end up meeting? So I've drawn this green line across, and those are the only spots, those 6 spots, I've put them with green dashes, those are the spots we can actually meet up, because that will have moved each of them 5 blocks, and since they're moving at the same speed, those are the only times when the amount of blocks you move equal the same amount. So we can meet on that diagonal line, and if you see, this forms basically a Pascal's triangle situation. So if we didn't see the Pascal's triangle, we could at least figure out how many different ways we can get to these spots, because this is a binomial situation. Every spot that you're in, you can go one of 2 ways. You can either go north or east. And then there are going to be 5 movements, so the number of ways we can get to the green line has got to be 2 to the 5, because we've got 2 choices at every move, and we're going to make 5 moves. 2 to the 5 is 32, so we know there's 32 different ways we can get to the line. We don't have to worry about getting how we get to spots before the line or after the line, because the line is the only spots we can meet. So there's 32 ways we can get to the line and 32 ways that our friend can get to the line. So we have to figure out how many ways that they match up, or what the probability of matching up. So let's think about the corners first. There is 1 out of 32 ways we can get to the corner. That's just all 5 moves north. And there's 1 out of 32 ways that the friend can get to that corner as well. So we have to multiply that. So that's 1 out of 32 times 1 out of 32. That's the probability that we both meet at this first corner here. It's going to be the exact same probability as how we meet at this first corner here. That would be 5 moves east for us and 5 moves south for them. One way of getting there for each, so 1 out of 32 is the probability for each one, because we have to multiply, because there's 1 chance that we get there, or that we choose to go that way, and then 1 out of the 32 ways that the friend will get there. That'll cause us to meet. I've labeled the other ones 5, 10, 10, and 5, because again, that's a row out of Pascal's triangle. But if we think about it really quick for how we got this 5, so that means there's 5 ways to get there. Well, that means we've got to go 4 east and 1 north to get to that point, in any order. So if we think of that as like 5 slots to fill in, it can go east, 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 north, or east, 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 north, east. In other words, the north can fill any one of these 5 spots. Therefore, there's 5 different ways of it happening, because the north can come in any of the 5 spots in terms of order. So there's 5 ways of getting there. Same thing with here, and you can do the same exercise to get to these ones. That would take 10 different ways. So the way we have to do this is continue this pattern. So 5 out of 32 for us to get to that next spot, times, it's also going to be 5 out of 32 for our friend, plus 10 out of 32 times 10 out of 32. So what I've covered here is how we're covering off this spot, and this spot, and then you can see it just repeats down the line. So we're going to multiply all of this by 2. So it's going to be 1 out of 32 squared plus 5 out of 32 squared plus 10 out of 32 squared. I'm just copying what's above, and I'm taking the whole thing and multiplying it by 2. In the end, if you plug that in your calculator, careful with brackets, you get 0.2461 basically. 0.2461. So almost 25% chance that you actually run into each other. That's about 25%. They want you to understand that it's binomial so that you can quickly figure out how many ways to get there. And then within binomial, there's that Pascal's triangle as part of the binomial theorem to figure out how many ways to get to each individual spot. So really tricky question, but drawing out the diagram and working through a couple scenarios hopefully allows you to see the pattern. You can always send us more questions or check out our YouTube video at Arnold Tutoring, our YouTube channel, or send us an email with questions, info@arnoldtutoring.com. Thanks.